I did grade the last quiz, and then I sent you the copies. Okay, it was a good quiz, you know. Almost everybody did a really good. I hope it's gonna translate, you know, when we do the test into the test, right? So that, you know, that the material, whatever we did in chapter 4, of course, will be in the test. You know, the factoring, you know, how to factor, you know, etc. The whole chapter 4, from factoring the GCF. I mean, we did that in test number 2. You know, whatever we did in test number 3. So the whole quiz number 3 will be also in the test. The whole quiz number 3 will be also in the test. So I hope when it's gonna be the test, I hope that everybody gonna do equally good. Okay. So of course, you know, the test, you know, has more pressure, okay, than the take-home quiz. That is true. But it's going to be the same exercises. Other than that, it's going to be what you did today or what you're going to do in chapter 5, right? This is like, you know, the beginning of statistics, how to represent or the histogram, how to do the histogram, how to do the also the what we call that, the bar graph, you know, etc., etc. So today we're gonna start our last chapter of this class, right? Pretty much we're gonna do it today, okay? Pretty much. So we're gonna do it, and it's gonna be about some calculations, how to some measures, how to find the you know, the mean, what you call the mean, right? How to find the median, how to find the standard deviation, those three stuff. Mean, median, standard deviation, and also how to find what we call the quartiles. Okay, so if we just limit to the basic of that, I have to say it's not like very hard if we just limit to the basic of that, okay? Which is the case in OED 2. We will not do, you know, something uh, way more complicated stuff like that. Okay, so it will be pretty much going to be about the basic of what I just said. So let me go ahead and try to, you know, share my screen. Hopefully it's going to be good, right? You know, my two classes, my two virtual classes, you know, during the day, I do them from A to Z, from beginning to the end, never having problems, almost never. But for your class, I don't know what happens, you know. Okay, hopefully it will not like throw me off every now and then. So chapter 6 is descriptive measures, right? So some measures, because we need some measures to understand data more. Chapter 6 is descriptive measures. Now 6.1 here is measures of the center. Measures of the center, right? So we will see like two types of center. The mean, which is like the center in a sense, you know, the calculation center, that is the mean. The median is almost like a physical center, okay? Almost as if your data are some type of physical things. You know, you align them, you go looking who is in the middle. What is the middle of your alignment? That is the median. The mean here is something that tells you what is the average, right? The average, which is more mathematical than the median, is really almost a physical. So, and you know, the mean is you add up everything and you divide by the number of data values, right? This is the mean. So let me put here the you know, the definition of that.
You there?
Nope, he went out again, I guess.
He said whenever he's trying to copy or paste something, it cuts him off. He's probably still talking.
All right, so this is what I was talking about exactly. You see, I mean, this is very, really puzzling for me. Is it because at this time we have, saturation of teams at this time, like in the evening? Is it because we have like a bunch of people using the stuff at the same time? That should be
It's a
the only,
possibility.
yeah, that should be the only reason. That should be the only rational reason, because I spent from, let me see, from 11 o'clock, 10 minutes, 11 o'clock, all the way to 2 o'clock, having two classes back to back, sharing my screen, doing all that, never had a problem, not even once. So, and that is puzzling to me. So, all right. So now what I'm going to do, I think I'm going to share the whole screen. If I share the whole screen, I think it won't do that. Okay, so now what is the mean? You can see my screen, right? The mean is the mean of a set of data is a measure of center found by adding the data values and dividing the total number of data values. That's it.
But it's small.
It's very small.
Mm-hmm.
So do you see it better?
Yeah.
Okay. All right. That is the mean. You add up all the values, you divide by the total number of values. If there is, that is like the regular average. Okay. Now we have some other averages, where we put weights, in each value. But here we don't worry about that. It's equal weight. So for instance, all of you need to know what is the mean of your quiz grade, right? You see, you add up, we did 3 quizzes, quiz number 1 plus quiz number 2 plus quiz number 3 divided by 3, okay? All of you need to know what is your mean of your test grade. We did 2 tests. You do test number 1 plus test number 2 divided by 2, etc. That is the mean, okay? So for instance, if you do this, for instance, and we pick up an example from the book, this data represent the number of shoplifters, right? This represents the number of shoplifters in a store during the week, or something, or during, so it says the number of shoplifters per week, right? For 13 weeks. For 13 weeks, they recorded how many shoplifters they have each week. Okay, and they got this data right here. If you ask you what is the mean, you go ahead, you add all them up. Okay, this Greek letter, it just use, this means some, does somebody know how we read this stuff? As a Greek letter?
Is that the pi?
Pi is this. This is mu, right?
Oh, that's pi, yeah.
That's mu. We read it mu, mu. So this is alpha, beta, right? Gamma, delta, etc., right? These are the small, the lowercase Greek letters. This is mu. So we call the mean mu. If you read in the book, in this textbook, you read mu, they mean the mean, right? The average, okay? So how we do the mean? How we do the mean here? I'm just gonna avoid over explaining, because you just add them up, right? 1 plus 7 plus 0 plus 2 plus 4, plus 5 plus everything, and plus 6, all divided by how many of them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, divided by 13, right? And what you have to do next is just take my calculator. Just avoid mistakes, right? That's it. Take my calculator, avoid mistakes, and that's going to be it. Okay, that is the mean. That is the mean right here. All right. So if your data is presented this way, we don't see no problem on finding the mean. It could be annoying if it is a large data. If you have like 100, a data of 100, size 100, it's going to be very exhausting to add 100 numbers, right? You agree with me? That's the only thing. That's the only problem with that. So now when we add them up, how much we get? We divide, we get what? Let me see the answer. The answer is 3.2. You see, after we do the division, we get about 3.2. Okay? That is the mean of this data. So now, the only other case where maybe we need to, let me see if they have it here. They even don't have that here. Okay. So now let's say we have a frequency table. Like, let me go back here. Organizing my data, and then I have a frequency table. That is not it. 5.2, I have a frequency table like this. Okay, so if I have this one, you ask you what is the mean? No, this is not this one, I'm sorry, not this one. I have to have a data that is not categorical, that is quantitative. No, this one is this one right here. Quantitative, no, qualitative data is this one. Okay. Not this. Okay, not this. Not this. Okay, let me just make it up. Let me make it up. So if you have this frequency table right here.
Can you go up a little, please?
Yeah, right this. Okay. If you have this frequency table, it says that is the data, that is a frequency. So we have 3 was given 7 times. 0 was given 2 times. 5 was given 13 times, right? And 6 was given 1 time. Okay, what is the mean here? Find the mean. Okay, so here, of course, this data is presented another way. Okay, this data is presented another way in the form of frequency table, which we know is a very economic way to present data, right? So for instance, if you wanted to write this data explicitly, it would be 3, 3, 3, 3, 3, 3, 7 times, right? And then 0, 0, and then 5, 5, 13 times, and then 6 1 time. You see? But the frequency table is a very economic way to present it. But now, if you ask what is the mean, right? You have to add up all the data. How many times we have 3? In my data, how many times do I have the data 3?
7.
7.
7 times. So what I'm going to do, I'm going to be 7 times what?
3 is going to give you 21.
Exactly. Plus, how many times I have 0?
2.
Plus 0 times what? 2. Plus what? How many times I have 5?
13.
5 times 13. And how many times I have 6?
1.
Only 1. 6 times 1. You see, that is a sum divided by, what is the size of my data? How many data I have?
14.
How we know
Oh.
that? How we know the size of the data? Remember, what column do we add up to
The
know what
data?
is the data or the frequency?
I would say probably the frequency.
Exactly, the frequency. To know the size of your data, you have to add up the frequency. So the frequency here is 9, 10, 23. So we divide by 23. All right, everybody see that? In a case, in a quantitative data, if you have a table of frequency, you can find the mean. You have to multiply each row together. You add them up. You multiply each row together. 3 times 7 plus 0 times 2 plus 5 times 13 plus 6 times 1. And then you divide by the size of the data. The size is you add up the frequencies, right? Okay. So nobody has time to write explicitly all this. You have 3 7 times. We have 0 2 times. We have 5 13 times. You see, nobody has time to do that, right? Okay. You have 6 1 time. But if you want to know what is the size of the data, you have to add up all those numbers. Okay. So we have the easy case, which is where you have like a single set of data right here. Or you have the case where you have to do a little bit more if your stuff is given as a frequency table like this. Now, the mean now, sometimes the mean does not tell the whole story sometimes, okay? Sometimes the mean doesn't tell the whole story. Okay, let's say I do a test in a class of 4, right? I do a test in a class of 4. I have somebody get test 1, test 1 right here, test 1. I have somebody, the first student getting, 45. The second student is getting 60. The third one is giving 65. And the last one is giving 100, right? What is the average here? The average is 45 plus 60 plus 65 plus 100, right? All over 4. It is, you do the math.
67.5.
You got 67.5?
Uh-huh.
Okay.
So would you round up at this point because you have a decimal to
no, you just leave it like that.
Okay.
Okay, that is the mean. But does the mean here tell the whole story? This class average almost a C, right? 67.5 is almost a C, almost 70. Okay, but look at the grades right here. This class needs help, right? Okay, because these 3 people, they are below the average, right? So 75% of the class is below the average. I have only 1 student who got 100%. So the mean here doesn't tell the whole story, okay? The mean doesn't tell how much this class is doing. So because this 100 is an outlier, this 100 is way out of the range, right? You see the range here, I can say, okay, my data here is from 45 to 65, and then I have a big jump to 100. So the mean here doesn't tell the whole story sometimes. Sometimes the median which is another middle, tells better story, tells the situation better than the mean, especially when the data has what you call outliers. Okay, if the data has outliers, the median will tell a better, will describe the situation better. That is the median. That's what we're going to see right now. Okay. Everybody understands the case, why we need another way to describe the middle, the average. You see, you come to a neighborhood, every house is $200,000, and then you have one house in the corner, that house is 2 million, right? Okay, if you do the average, will the average price will tell you exactly the story? You see, the house which is 2 million, of course, the average will say, it's going to have like a big impact on the average. But the truth is, in this neighborhood, the average price is like 200,000. That is the truth. We have only one house, which is $2 million. Okay. So in that case, we need what you call the median. The median is almost like a physical center. You see, the median is almost like a physical center. That is almost just like a median. So how we get the median? So, measure of variation center. Okay, the median is, let me write the definition here first. The median of a data set is a measure of the center that is the middle value when the data values are sorted from smallest to the largest. This measure splits the data into two equal parts, right? Half of the data values are below the median and half are above the median. That's the physical, it's like almost a physical middle. Okay, everybody line up. Everybody lines up and then you pick up the middle, the one who is in the middle. That is the median, okay? Everybody line up and then we pick up the one which is in the middle. So now let's pick the same one right here. Let's pick the same one right here and find the median. Example, oh, sorry. We're gonna try to find the median. Okay, how we get the median? First, what we do to find the median.
You gotta put them from smallest to biggest.
Thank you very much. We reorder them from smallest to the biggest. The smallest is 0, right? And then we have 3 ones, right? 1, 1, 1. Do you have any 2? We have 2 2s, 2, 2. And we have any 3? 1, 3. 2 4s, right? 1 5 or 2 5s. 1 6 and 1 7, right? 1 2 3 4 5 6 7 8 9 10 11 12 13. Okay, that is the reordering. Now what you do now, we just go ahead and look at what is the position of the median. What should be the position of the median? Now we have 2 ways to go after that. Some people prefer this way. You see, some people prefer this way. This, I cross out left to right, left to right, okay? Left to right, left to right, left to right, left to right, until I get this one. Okay? This way, why this way sometimes cannot be, could not be like sustainable sometimes. In what case this way is going to be hard to do?
When
If you have what?
When you have even, like the even.
Yeah, we're going to see the even case. This way could be hard to do if you have like a, you know, a big size data, right?
Mm-hmm.
Imagine yourself doing this like for 20 minutes, you see? Imagine somebody doing, okay, cross left, cross right, etc. for 20 minutes. You see, this way could be exhausting, but you know, it is a good way to find the middle here. Now, in this case, we have a single number that is in the middle, right? Because the size of the data is even. The n is even, the size of the data n is odd. The size of data equals 13, which is odd, right? Now the median is at what position? What is the position of the middle? 1, 2, 3, 4, 5, 6. It is at the 7th position, right? There is another way, mathematically, there is a mathematical way to find the 7th position. You see that 7th position, there is a mathematical way to find it. What is that mathematical way? What is the size of the data? Position of the median. What is the size of the data? It's 13, right? 13. and you add 1, and then you divide by 2. The size of the data plus 1 divided by 2, if it is odd, right? You see, the size of the data plus 1 divided by 2. Do the math. How much does this give you? Is it 7?
It's going to be 7. 13
Exactly.
plus 1 is 14, divided by 2 is 7.
Exactly. So if you want to find the position of the median, you can add up the size of the data, you add 1, and then you divide by 2. Okay?
That's interesting.
So now, if it is give you, that is one, if it is give you a whole number, it's give me a whole number like this, that number is exactly the position of the median. The median is at the 7th position. Is at the 7th position. After you order them, okay? After you order the numbers, your median is exactly at the 7th position. You guys see that? Now we're going to see the case when we have an even number of of data. This case, we have an odd number of data. The median is kind of easier to find. Okay, the median is easier to find. So now, if you have an even number of data, so let's pick up an example where you have an even number of data. Okay, so we have this one. It's about almost the same thing. Right here, right? By the way, if this represents the number of shoplifters every week, right? Now we go to the 14th week. What do we see in the 14th week? Is it usual? Is 30 a usual number? It's, look at every other number. Look at 30. 30 is what we call an outlier, you see? Every other number is between 7 and 1, right? 7 and 0. Every other number is between 7 and 0. And then suddenly you have 30. If you have the store owner, and in the week number 14, you have 30 shoplifters, then you have to say, okay, something is going on, right? Okay, so this is not a normal case. So now find the median. What you do? Find the median. The median will be, we do the same thing, right? We reorder them. We have 0, we have 1 3 times, 1 2 3, we have 2 times, and then we have 3 1 time, we have 4 2 times, right? We have 5 2 times, we have 6 1 time, we have 7, and then we have 30. 1 2 3 4 5 6 7 8 9 10 11 12 13 14. Okay, I have the right size. Now what you do now? Again, we can do the other, the crossing out. Let's cross out the first option. Let's cross out and see this. We cross out left, right, cross out left, right, left, right. Okay, left, right, left, right, left, right, and then I have 2 left. I have 2 of them left. I cannot cross them out, because if I cross them out, I will have no number to say. I will have no median. What I do? The median will be the 2 left. I add them up. I divide by 2. Will be 7 divided by 2. Will be 3.5. Sometimes the median is part of the data. Sometimes the median is not part of the data, okay? All right, the median does not have to show up in the data. In this case, do you see 3.5 anywhere? We don't see 3.5, right? It is the median. It does not show up, okay? You see here, right here, 3 is a median, and we see 3. 3 is exactly the median, right? Okay. So now look, how can we get to this answer without crossing out? How can we get? What is the product of the median? What we do? Let's do the number of data, which is 14. We can locate the median like this. We also can locate the median.
Mommy, help me, mommy. Help me.
The median as follows, right? Okay, what you do? What is the size of the data? Is 14, right? 14 is the size of the data. Plus what? Plus 1 divided by 2. We're going to do the same formula, right? What is 14 plus 1 divided by 2? It is 7.5, right? But since it is 7.5, can I have 7.5 position? Can you have like a decimal position? Does it make sense? Everybody, does it make sense to have a decimal position?
No.
It doesn't make sense. I mean, if people, can I say, okay, this one is at the first, this one is in the first place, at the first place, you are in the second place, and then John is at the 3.5 place. Does that make sense? It doesn't make sense, right?
No. Well,
Would we round up?
So we will not round up exactly. What we're gonna do here, we're gonna do, since it is 7.5, we're gonna do what? 7th position plus 8 positions divided by 2, that's gonna be the median. It's not 7 plus 8, I want to say 15, okay? It is the number at the 7th position plus the number at the 8th position divided by 2, okay? That's gonna be your median. You see 7.5? You're gonna add up the two numbers located at the 7th position and the number above, which is the 8th position, you divide them by 2. What is the number located at the 7th position?
3.
3. Everybody see that? You see, we count 1, 2, 3, 4, 5, 6. This is the 7th position. It's 3. What is the number located at the 8th position then?
4.
4. That is the 8th position. Plus 4 divided by 2. What we get? We get exactly 3.5. Exactly this, right? Everybody sees the two ways. Which way is more mathematical? Which way is more mathematical? I know you guys. I know you guys like the crossing way, right? I know that. But the way the formula is more mathematical, right? But you know, if it leads you to the right answer, you know, it doesn't matter. Okay, it doesn't matter which way to go. If it doesn't lead you to the right answer, okay. But you have the median locator. The median locator is very easy. You say the size of the data plus 1 divided by 2. The size of the data plus 1 divided by 2, right? If that is a whole number, that number is exactly the position of the median. If that calculation gives you a whole number. Now, if it gives you something 0.5, okay, then you add up 2 positions, you divide by 2. That's it. Okay, but you know, both ways works. Like I said, both ways work as long as we have the right answer. So now let's see. Let me give you. You see, what is the advantage of the median over the mean? The advantage of the mean is the median is not very sensitive to outliers. Okay, the median is not very sensitive to outliers. The mean is very sensitive to outliers. It's the mean, like, you know, you have a balance, you know, the balance. The mean is like, you know, the stuff that is the middle of the balance. So now if you put some more weight somewhere, the mean has to adjust. But the median sometimes does not adjust, you know, to outliers, okay? That is the thing. Okay, so now let's see an example like that. Okay, so we're gonna first do an example that is just straight calculations. All right, everybody, try to do this one, please. I'll let you some good 5 minutes where everybody try to find the mean and the median. Now, by the way, for the mean, do we need any reordering for the mean? Is it mandatory for the mean? It's
No.
not.
No.
For the median, is it mandatory?
Yes.
Yes.
It is. Yep. Exactly. Go ahead, please. All right. What is the mean, everybody, for this one?
6.
Everybody got 6? So we add them up and we divide by how much?
2.
By 11.
Yeah,
So you
by
said 6?
I was gonna say, how did you come up with 6?
Yeah, 6 is a low number. You see?
It should be 31.72.
Yes.
31.72. Thank you. That is a more, that is a, you know, that sounds like
Yeah, that's what I got.
yes, exactly. So this is 43 plus everybody plus 37 plus, you know, plus 35 plus 30 plus 41 plus 23 plus 33 plus 31 plus 16 plus 21 plus 39, all divided by 11, right?
Right.
And you get this, okay? That's the mean. 6 is a very low number. For the simple reason, there's no data that is even close to 6, right? Okay, so now the median. Okay, what is the median you got?
33.
You got 33, everybody agree with that? Okay, so let's
Yes.
order them. We go from 16 and then to what?
21.
21 and then?
23.
23,
Uh-huh,
30,
30, yes.
31,
1.
Uh-huh,
30, 33,
33,
35,
35, and then?
37,
Uh-huh,
39,
41
41, and 43.
and 43, right?
45. Yes.
Okay, now, if you go by the median locator, we have 11. We say 11 plus 1 divided by 2, which is 6. This is the 6th position, right, of the median, of the median. The median is at the 6th position. 1, 2, 3, 4, 5, 6th position. You can also go with the crossings. You see, cross, 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 and then cross, cross, and you get 5, 6, right? This is like the 6th position. All right. So, you know, imagine you have, this type of question in a test, right? So, all right. So we have this one now, which is a data plot. Okay. A data plot right here. And we ask you how many students were in the class, what is the mean number of credit, what is the median number of credits, okay? Same thing, I'll let you like few minutes to answer to these 3 questions. Hi, everybody. How many students were in the class?
16.
16.
You said 16. So we just add up the number of dots, right?
Mm-hmm.
We have 1 here. We have 2, 1, 1 plus 1, 2, plus 1, plus 2, plus 3, plus 1, plus 4, plus 2, plus 1, right? 3, 6, 8, 10, 16. To find the mean here, we're going to add up the data. This resembles what I was explaining about the frequency table, right? Okay, it resembles that. All right, so we have 3 how many times?
1 time.
That's for the mean, right? Plus 4 how many times?
1.
1.
5 how many times? How many times 6?
2.
2 times 6. 7 is how many times?
3.
3 times 7. Plus 9 1 time. Plus 10 4 times. Plus 11 2 times. And plus 12 1 time. All that divided by 16. How much you got for those who did that? Everybody did that, by the way?
No,
No, I didn't.
No.
to be honest.
Yeah, because if you decide to write them explicitly, if you decide to write all of them, this is what you're gonna get, right? I mean, here we have only 16 data, so this is what you're gonna get. You're gonna get 3, 4, 5, 6, 6, 7, 7, 7, 9, 10, 10, 10, 10, right? 11, 11, and 12. You agree with that?
Yes.
This is exactly what the data plot represents, right? Now, how many times we have 6? You see, is 3 plus 5 plus 3 plus 4 plus 5 plus, how many times you have 6? 2 times 6, right? How many times you have 7? 3
2.
times 7, right? How many times you have 10? 4
4.
times 10, exactly, etc., etc. 11, 2 times 11, you see? So you don't need to write explicitly this way, but I agree for you. If it's better, if the data is not like 100 stuff, okay, 100 stuff in a test, it's gonna take you a very long time to write it down, 100 numbers. But if the data is only 16, okay, you can write them, all of them, explicitly, okay? That way it's gonna be more visible. Okay, everybody agree with that? Everybody agree that this is the way we find the mean. We add them up, and then you multiply every data. You multiply every data by the number of dots you have there, right? Every data you have here, you multiply by the number of data of dots you have. I have the data 3. I multiply by 1. Data 4 by 1. Data 5 by 1. Data 6 by 2. Data 7 by 3, etc., etc. Data 10 by 4. Data 11 by 2, etc., etc. This is how we get the mean. And then you divide by the total number of students, right? How much you got for everybody who did that?
8.
You got 8?
Yes.
I'm going to trust you. So the mean is 8. 8 credits, okay? Okay, now that we have all our data is written explicitly, what is the median now?
1.
The
I
median
got
is 1.
I got 8.
You got 8.
Mm-hmm.
You got the same number for the mean and the median. It could be, right? Okay, let's try to do, either you do the crossings or either you do the median locator. You add the number and then you divide by 2. Okay, which one you prefer? The crossings?
I did both, just to
did
make sure I
both?
was correct. Mhm.
Okay, let's do both. Let's start with the formula. The locator, median locator formula. What is the number? What is the total number of data? 16, right?
Mhm.
It says 16 plus 1 divided by 2. This is 17 divided by 2. This is 8.5. Which means what positions I have to add up to get the median? What are the positions I have to add up to get the median? The 8th position plus the 9th position divided by 2. Okay? If you get 8.5, you add up the 8th position and the 9th position, you divide by 2. Not the 7 and the 8. 8.5 is the one and the 8 and the one up, the one that's the next one. 8 plus 9 divided by 2. Again, it's not 8 plus 9, is 8th position plus 9th position divided by 2. Now, the way I wrote this, my data, is my data ordered? Is it in the right order?
Yes.
Who is at the 8th position?
7.
7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. This is 7, right? Who is at the 8th? No, I mean the 8. Oh, I'm sorry. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8. This is 8th position. Who is at the 9th position?
The 9th.
9 position. And then I divide them by 2. It's going to be 7 plus 9 divided by 2, which is also, this is not exact, this is exactly 8. You see? In this case, the mean and the median, they happen to be exactly the same number. It does happen. Okay? It does happen. If you have this, what this stuff teaches me, it teaches me if I have another representation that is not like, that's the data, if I have a table of frequency, if I have a data plot, if I have stem and leaf, etc., if I have all those presentation, if the size is not excessive, I can go ahead and write them explicitly. If the size is not excessive, okay? So this is what this stuff teaches me. All right, so let's see if I have another problem before we go to the next one. Okay, you see this right here? All right, okay, so now we're gonna go ahead and do the next measure that we're gonna try to do. By the way, do you have any questions about this stuff, how to find the mean and how to find the median, everybody? Do you have any question about that? How to find the mean, how to find the median? In the test, I promise no tricks, right, on the test, okay? There will be no tricks. It's gonna be like, some regular problems, okay? All right, so now the measure of variation. This is the next one, the measure of variation, what you call the standard deviation. The standard deviation is a measure that's basically, it tells us how spread is a data, if the data compact or is the data not compact. That's the standard deviation. So for instance, the mean doesn't tell how compact my data is. The mean doesn't tell that. The median doesn't tell how compact my data is. Okay, the median doesn't tell that. The standard deviation is a standardized way to measure how people are spread around the mean. You see, basically, just to give an idea, this is the mean right here. Everybody, the mean is here, is at this location, right? The standard deviation is a way to calculate how far away, how spread we are around the mean. is the data very close to the mean, or is the data very, very scattered around the mean? For instance, just to give you an idea, if I say we did a test in this class, and the mean was 75%. That was the mean, right? A C. Okay, the mean is 75%. Okay, that is a good test, right? That's a good test, because some people got below 75, some people got above 75. But now if I do this now, if I say the standard deviation is 15. What that means? It means we have recorded 75 plus 15, which is 90%, up to 90% was recorded during this test, or also down to 75 minus 15 is 60, down 60%. You see, which means the big bulk of the data is between 60 and 90. Okay, that's basically that, how spread we are around 75. How spread are we around 75? It means some people got all the way to 90, some people got all down to 60, and the big bulk of the test is between 60 and 90. Maybe somebody got 100, maybe somebody got a 35%, but the big bulk of the class is between here. That's the standard deviation. That is the meaning of standard deviation, right? Okay, so now if I say it's the same, if I say we did a test, the mean is 75%, but the standard deviation is only 3. What that means? The class who got standard deviation 15 and the class who got standard deviation 3, who did better? With the same average, who did better? What do you think?
Explain that again. I'm like so lost.
Yeah, I don't understand.
I do not understand at all.
Yeah, we're gonna define standard deviation, but I said it was the standard deviation is a way to measure how spread the data is around the mean, the average, right? Okay, I give an example. For instance, in your test number 2, let's say your test number 2, I did the average, the regular average. I add up everybody's grade, I divide it by the number of you, right? Let's say you are 20 students, I add up all the grades, I divide it by 20. I got 75%. But we said 75% doesn't tell the whole story, right? If I really want to study, if I really want to understand the data of the test, the mean 75 doesn't tell me everything, right? Okay, it doesn't tell. That is just that. The mean doesn't tell. The mean does not tell the whole story of the data, right? Now, if I say the standard deviation, we're going to define. We're going to see how to calculate it later. But I want just to give an idea what that means. If we say the test number 1, the mean is 75, but the standard deviation is 15, which means the deviation around the mean, the deviation from the mean, go 15 on both sides. Okay. 75 is the middle, right? 75 is the middle. The deviation, the standard deviation from the 75 is go above 15, below 15, right? What is 75 plus 15? It's 90, right? Everybody?
Yeah.
What is 75 minus 15?
60.
It's 60. It means when you give me these two data, you say the mean is 75, the standard deviation is 15. In my head, I said, okay, the majority of the class, the grade of the majority of the big majority of the class is between 60 and 90. That's what standard deviation means. Okay. The middle here, this is the mean, is 75 is the middle, right? This is the mean. The big chunk of the class, maybe like 15 of you, all your grade lie between 60 and 90. This is what standard deviation means. 75 plus 15 is 90. 75 minus 15 is 60. Okay, the standard deviation. You see, deviation is how far away you are from something, right? That is deviation. Okay. So now I said, if I have another class now with the same mean, they did the same test, where the average is of the test is 75, right? But now the standard deviation is only 3. The big chunk of the grades will be expected between what and what?
72 and 78.
Thank you very much. 72 to 78. Because 75 plus 3 is 78. 75 minus 3 is 72. Now, of the two classes, who did better? If you go to the passing stuff, pass, fail.
The second class.
The second class did better, right? You see, the standard deviation is a complement. It's a complement of measure. You have the mean. It tells you what is the middle, what is the average. But the standard deviation tells you how spread we are around the mean, right? How spread the data is around the mean. That is why you have the word deviation in it. The standard deviation from what? From the mean, okay?
Mm-hmm.
The standard deviation from the mean, okay? That is standard deviation,
Okay.
basically. So now, in the standard deviation, we have a formula, right? How to get the standard deviation. But I will not give you the formula because the formula will confuse you, right? Look, everybody, look, this is the formula right here. Do you see the formula?
Yeah.
You after you see the formula, do you want me to give it to you?
No, not really.
Nope.
Okay, so let's look at the symbols we have. We have the big stuff right here, the big, this big thing.
Yeah.
Some of you know that. How you call that? This is a
The root,
square root. Thank you. And then we have this one right here.
that's the sum,
That's a sum. Thank you. How you know that?
because I do accounting.
Exactly. In accounting, we use a lot of sums. Exactly. That's a sum, right? So basically, this formula involves summing, adding up numbers. X is the data, mu is the average with the mean, and n is the number of, is the size of the data. Okay? So that is the standard deviation. So now we have to, let me see. So now we will not use this formula, but I'm going to show you how to find the standard deviation, doing the whole formula, but not writing this explicitly, right? So let me give you, let me take a data right here. Okay, so we have this one right here. Okay, that's 6.2, standard deviation. Okay, so this is my data. It's small number of data, only like five of them, right? So what we do, we find, you see here, they say find the range. So range here, actually is a very common word. If you have my data here, what is the lowest data?
One.
What is the lowest data?
One,
One.
What is the highest data?
6.
6.
What do you think is the range? Even if this is the first time you heard about it, just in your imagination, what would be the range there?
It would be, is it all the numbers multiplied, subtracted by how many it is?
No, that is overdoing it. I say the range here. You see, for instance, we say this data, they range from what to what?
1 to 6.
1 to
1 to
6.
6. So what is the range then? 6 minus 6 minus 1, right? The range is the highest data,
Highest. Okay.
the highest data minus lowest data. As simple as that. That's right. Which is 6 minus 1, which is 5. Again, why we need to know that in statistics? This all goes to how spread my data is. If the range is small, if your range is small, what it tells you about your data? Is it very spread or not spread?
It's gonna be small.
If the range is small, my data is not spread, right?
Right. It's gonna be
If the
small.
range is large, then my data is spread.
Mhm.
If we did a test, my range is only 3. It means all your grades are within three grades, 3 numbers, right? If you did a test and then the range is 95, what that means? It means if you subtract the highest grade in this test minus the lowest grade, it is 95. Probably somebody had a 100%, somebody have has a 5%. You see, which means my data could be very, very spread, right? Okay, that is the stuff of the range. Now, how we do the standard deviation? The standard deviation, we do this. To do the formula, which is this is a formula. Square root of x minus mu squared divided by n. You see here in the textbook, they said divide by n, but I'm going to come back to that. I'm going to come to this. First, what we do first, to find the standard deviation, I do this type of table. First, find the mean. That's the first. What is the mean? 1 plus 4 plus 3 plus 2 plus 6, all over 5, right? Which is what? 16 divided by 5, which is, right? Is it 16? Yes, 16 divided by 5, which is
3.5.
3.5. Okay. Now I do my very nice table, very, very nice table here, where I do this. That is the data right here. That is, I do the data minus the mean. That is the data minus the mean square. Okay. We're going to do these 3 calculations. My data is 14326. I don't need to reorder them. 14326. Now, I'm going to subtract everybody the mean. I'm going to do everybody minus the mean. 1 minus 3.5 is how much? Negative 2.5, right? 4 minus 3.5 is how much? 0.5. 3 minus 3.5 is how much? 0.5. No, negative 0.5. And then we have 2 minus 3.5 is negative 1.5. Okay? And we have 6 minus 3.5 is 2.5. What I'm going to do, I'm going to square these numbers. I'm going to do negative 2.5 squared. How much is that?
5.
2.5 squared is
5.
6.25, right?
6.2.5. Negative.
Exactly. No, it's going to be positive anyway because you square everything, right? If you use the calculator, you have to put parentheses around the negative sign.
Oh, okay. I didn't do the parentheses.
Yes, and 0.5 squared is 0.25, right? Negative 0.5 squared is also 0.25.
Okay, I got you.
Negative 1.5 is square is 2.25, right? But you know, check that with me. And then finally 2.5 squared is 6.25, right? But see, so far, all of you see what we did? All of you see what we did? so far? You do your data here. You don't need to have them in order. You don't need to. Prior to that, you have calculated the mean right here. You do everybody minus the mean, and then you square those numbers. Everybody minus the mean, you square those numbers. What you gonna do next? You see, what we did here is we did this right here. We did this. Is what you did. Now then comes the sum, the sigma sum, which means we have to add them up right here. Okay, that is the sigma sum. We do 6.25 plus 0.25 plus 0.25 plus 2.25 plus 6.25, right? Which is 15.25. Okay, 15.25. All right. Now we did what? So far we did what? We did this part. We did the sigma. We did the sigma so far. Now what's next? The next time now is to divide by n, and this is where we need to talk a little bit, because in the standard deviation formula we have two types of formulas. We have two divisions. We divide by n when we're talking about a population. If we divide by, if it is a sample, then we would divide by another number, okay? But here, since we have to follow the textbook, you see here, they even didn't talk about population or sample or something like that. But if we go to another class, don't be surprised if instead of dividing by 5, they divide by 4, okay? Don't be surprised. We're gonna follow the textbook. The textbook says divide by n. They didn't say if. They didn't say that. But if you go to 125, math 125, they give you the two cases. Sometimes you divide by n, which is the population standard deviation, what we call that. Sometimes you divide by n minus 1, which is the sample standard deviation. But since here in 082, they even didn't talk about population or sample, they didn't talk about that, we're gonna follow that. We're gonna follow exactly what that, we're gonna divide by 5, right? So 5 is what? The size of the population. So we're gonna do next, you see, the first step, do this. The second step is do my table. The third step, do divide that sum by the size of the population. And that size is how much? That size is 5, right? So we get 15.25 divided by 5, which is how much? 3 point what? 3.05, right? .05. Now we're not done yet, right? That is the division. So we are here, we divided by n. Now what's left to do? What is the last step? What is the last step? Take the square root. Which is square root of 3.05, and here you have to use a calculator. Everybody, if you look at your calculator, you're gonna see the square root like this. You see, square root 3.05 and then square root. You see, how much is 1.73 or 1.74 if you round? That is the standard deviation. Okay.
Front door.
Yeah, that's a lot of steps, huh?
Yeah, so especially if the data is a big number of data, I agree with you. But if it's a small number of data, you find the mean first, and then you do this very nice table right here. You see, look at the nice table what you did. You want to subtract everybody from the mean. Although everybody minus the mean, everybody minus the mean, right? And then you square those numbers. The calculator has a very big participation in this because the numbers usually they are not nice and we need a calculator, okay, usually. And then you divide by n. N is a number of data here. You see the size of the data, which is 5, and then you take the square root. That's going to be a standard deviation. Okay, that's going to be your standard deviation. So, all right, so let's do another one right here. Let's do another one, and then you're going to do it, of course. After this one, we're going to take the break. All right. Of course, my table here will be a little bit longer table because we have 1, 2, 3, 4, 5, 6. We have six data, right? Okay, you're gonna find the range, and then you're gonna calculate the standard deviation. I'm gonna let you like for everybody to get a chance to do exactly the steps we did. I'm gonna let you 10 full minutes, everybody. Okay, 10 full minutes for everybody to get a chance to do exactly what we did. All right, I think by now I think at least some of you maybe did finish. So how much you got for standard deviation? About how much?
I got 10.77.
10.77.
Mm-hmm.
All right. So did you take the square root of that?
Yeah. Wait, the square root of this?
Yeah, I mean, I don't know. So this number to me looks like a little bit high number.
Oh,
I
14.
got 1.34.
1.34. Okay, let's look at the key. 4.4. Okay, so of course, in the standard deviation thing, it's very easy to do mistakes. Okay, that's for sure. Okay, let's do together. First, we get the mean, right?
Mm-hmm.
The mean here is, I mean, what is the range first? What is the highest number?
The range is 14.
20 minus
6.
6 is 14.
14.
exactly.
I got that.
Now for standard deviation, we do the mean, which is 15 plus 10 plus 6 plus 15 plus 20 plus 12 all over 6, right?
I know what I did wrong.
Mm-hmm.
Okay, so we get 25, 40, 46, 66, 78,
78
was-
over 6.
which
Over-
is what?
13.
13. Okay, I got that.
13 point what? Is exactly 13, right?
It's
Yeah.
exactly 13.
Same.
What I
Exactly
got.
13. That is a good thing. So now we do our table like this, right?
Mm-hmm.
Yeah.
That is the second step. We do the data right here, the x. That's the data minus the mean. Now this is the data minus the mean square. Okay, so we have 15. 15 minus 13, which
It's
is 2.
2.
2 squared, which is 4.
Uh-huh. So I got it.
10 minus 13, which is
Negative
negative
3.
3. Negative 3 squared, which is 9.
Got that.
6 minus 13, which is negative 7. And negative 7 squared, which is 49.
Okay, I got that.
15 minus 13, which is 2. And
Negative.
2 squared, which is 4. 20 minus 13 is
7.
7 also. 7 squared is 49.
49. Okay.
Finally, 12 minus 13 is negative 1. And negative 1 squared is 1.
Got that.
And then we
Okay.
add them up, right?
Yeah.
Everybody got
Mhm.
that?
Yeah.
Yeah.
Add them up, we get how much?
116.
116
116.
divided by
The-
6.
That's the part that I
Yeah.
messed up on. I forgot
Okay,
to divide by 6.
Exactly. 116 divided by 6, we get
And then it
about
gives you
It gives you
19.33.
19.33.
Yeah.
33.
33. And then the last step is
Square
square root.
root
The
it.
square root and it's 4.39.
Yeah. Okay.
Okay, so that's what I didn't get. I got third. I didn't get that. 19.33 square root it.
Yeah, and then you get 4 point something, right?
Eight.
I got-
That,
I
yes.
keep getting 373.64. I
Yes.
got everything
That's
all the
okay.
way up to there.
Mm-hmm.
So I did the
That's a-
square root.
That's a big number, right? So
It is a
this
big
is how we calculate the standard deviation. Now we're gonna take a break. Of
I
course,
got
in the test,
4.8.
we got 4.8.
Yes.
I mean, so it could be, it could be a reasonable difference between the decimals, but not that much.
Okay.
4.39, 4.4, 4.30, etc. But if you get like something 4.8, probably, a mistake is somewhere, a little
But
mistake
I
somewhere.
don't see how you got the 4.39. I got the
Me either.
19.33. You got to pick me up to get me
I
to
mean,
the
I heard somebody tell me 4.39.
Yeah, I got 4.39. That's because I square rooted.
That's the square root of 19.30.
Yeah, 19.33.
That's where we get the
19.33. When you take the square root of 19.33, you get 4.39 or 4.4. You can round. Okay?
Mhm.
You agree with that? So 19. So here, everybody agrees with us.
Okay. I see what I did wrong.
Okay.
I figured it out. Thank you.
All right. Okay. So we're gonna take like 10 minutes break, everybody.
Thanks, girls.
You're welcome.
You're welcome.
Yeah, and then we're gonna come back at 7:25. Okay.
Okay.
Thank you.
So lost.
All right. Welcome back. So maybe we need to do another one, maybe.
Yeah, we can do another one.
Okay, so let's do the number 5. Okay, so now we have 2 accountants, something like that. Maybe. So counting. All right, so let's bring them up here. Okay, the table below shows the preparation tax returns time in hours of course CPA, right? Accountant X, accountant was Z. Find the range preparation for each accountant, right? Calculate the standard deviation for each one of them. Who has a more consistent tax preparation time? So I'm going to give you again, some good like good 10 minutes for everybody. Try to do that.
Rittenhouse doesn't seem eager to talk about it, but I talk down to you. His lawyers did.
All right, everybody. So, okay. So what is the mean for the first accountant, accountant X? How much is the mean?
8.
You got 8? Everybody agrees 8?
Yes.
121. 8, right? What is the mean for the second one?
8.
8.
Also 8, so they have the same mean, right? You see here, this problem right here, the goal of this problem is to say the mean doesn't tell the whole story, right? I mean, the mean does not allow us to understand fully the nature, because here we have two different data that have exactly the same mean, right?
Mhm.
The standard deviation will elaborate more about the two set of the data, okay? The standard deviation will tell us more about that. So now what we're going to do is the standard for the first one now. Everybody, please look at the step. I mean, I think you have the answers. Let's do the first one. So we do, right here, we do the 7, 9, 5, 11, 8. So we have 7 minus 8 is 1. I mean, -1, right?
Mhm.
And the -1 square is 1. We have 9 minus 8 is 1. 1 square is 1. We have 5 minus 8 is -3, right? And the -3 square is 9. We have 11 minus 8 is 3. And 3 minus 3 squared is also 9. Okay? And finally, we have 8 minus 8 is 0. 0 squared is 0. So we add this up, we get 20, right?
Mhm.
We divide 20 by what?
5.
We get 4, right?
Mhm.
And then we take the squares of 4. So the standard deviation is, sometimes they call it sigma. Sigma, small sigma like that, right? When you see sigma like that, it means standard deviation, okay? This is mean. This is standard deviation. It's going to be square root of 4, which is 2.
Yeah, that's what I know.
Okay, so now the other one now is we have this. We do the same thing. We have 5, 11, 14, 3, and 7. So 5 minus 8 is -3, and the -3 squared is 9, right?
Mhm.
So you have 11 minus 8 is +3, which is 9. 14 minus 8 is 6, this is 36. 3 minus 8 is -5, this is 25. And 7 minus 8 is -1, this is exactly 1. We add them up, how much we get? We get,
80.
said 80, right?
Yes.
Mhm.
We get 80. And we divide 80 by what?
5.
So we get 16, right?
Mhm.
So the standard deviation is square root of 16, which is 4.
4.
Now, to answer to this question, who has the more consistent tax preparation time? Is it the first accountant or the second one?
The second.
The second one has the highest standard deviation, which means, you see, which means the average is 8 hours of preparation, but it can go all the way to 12. 8 plus 4 is 12, or all the way down to 4 hours, right? Sometimes he completes preparation in only 4 hours. Sometimes he goes all the way to 12 hours. But the first accountant, the standard deviation is only 2. It means sometimes he can prepare 8 plus 2 is 10 hours, or sometimes 6 hours. But usually between 6 and 10 hours. The second one is between 4 and 12 hours. So who is more consistent? Who's more consistent?
Wait, explain that one more time.
Yeah, please.
The first accountant, the standard deviation is 2, right?
Mhm.
The average preparation is 8, right? That is average preparation. In any given day, the average time would be 8 hours, right? But sometimes he can go all the way to 10. Where's the 10 come from? Where's the 10 come from? I said 10. Where's the 10 could come from? 8 plus what? 8 plus 2, right? The standard deviation, 8 plus 2 is what? 10, right? Or sometimes he can go all the way down. He can be fast and prepare into 8 minus 2 is 6, right? So if it is very fast, he's going to be 6 hours. If he is very slow, he's going to do 10 hours, right? Between 6 and 10, okay? That is, that is, you know, his most preparation time is between 6 hours and 10 hours.
I'm still confused.
I mean, this is like some type of margin of mistake. In any given day, your average preparation is 8 hours, right? You need 8 hours to prepare the file. But what the standard deviation tells you? It tells you you can go all the way to what? 2 more hours. What is 2 more hours?
10.
10 hours, right?
Mm-hmm.
Or if you are very fast, you can go all the way to 6 hours.
Mm-hmm.
That is what the standard deviation tells. It tells the standard, you see the word standard deviation, which
Mm-hmm.
means usually we do 8 hours, but maybe sometime we do 6, maybe sometime 10, right? Okay, 8 plus 2 is 10, 8 minus 2 is 6.
6.
That's it, okay?
Mm.
So for instance, my time to grade is 3 days. That is average time. I grade papers in 3 days. But my standard deviation is 2 days. What that means?
Mommy, fun.
It means is I'm very lazy, right? If I don't have time or I'm feeling lazy, maybe I'm gonna do 3 plus 2 is 5 days, right? Or if I you know, I'm very like, you know, I'm very motivated, maybe I can grade my papers in only 1 day, which is 3 minus 2 days, right? That's the story of standard deviation, which means the accountant number one does his stuff between 6 hours and 10 hours, right?
Mm.
The second one now, the average time is 8 hours.
Mm-hmm.
But sometimes he go all the way to what? If you feel not motivated, or if you know, if you just, you know, some laziness, you go all the way to what hours? How many hours?
12.
12 hours, yes. Don't hesitate. 8
Oh,
plus
okay.
4 is 12.
Okay.
Or sometimes if it is like very, very motivated, you know, or if you like paid a lot of money, he does it in how many hours?
4.
4.
Only 4 hours, right?
Mm-hmm.
So who is more consistent in preparation time? Who is? Look at now, look at the intervals. Who is more consistent?
Z.
More consistent means the times, the interval time is more, is a smaller interval time. This guy is more consistent right here.
Right. Okay. Got it.
Yeah, this guy is more consistent because, you know, look at between 12 and 4. You see how much is that, the gap?
Yeah.
Okay.
I get
Okay.
it. Okay.
Yeah. So that, you know, the standard deviation tells you how spread your data is. What is the spread of the data? That is the standard deviation. It tells you about the spread of the data. Okay? So we need, of course, those people who want to understand data, they just don't want to take the average or the mean. You know, they need a lot of stuff. They need to understand the data very well. You see, these two sets of data, they have exactly the same mean, right?
Mm-hmm.
Which means, and you look at them, look at the data right here. Even before the standard deviation, look at the two data. Don't you see the first one is more consistent? Don't you see that? Isn't it the first one more compact right here?
Yeah.
Yeah, I mean, if you just, you know, if you just like in the nude eye, when you look at this, I see the first one, I have 7, 9, 5, 11, 8. But look at the second one. I have 14, I have 3, I have etc. See? But that is just my impression. But when I do the standard deviation, definitely it tells me the whole thing. It tells me the first accountant is more consistent, right? In a preparation time.
Mm-hmm.
So something we're gonna see here is, for instance, we say how, so how I can say that? Okay. You and I, we are in two different classes, right? I am in my class, you are in your class. We did test number 1. You scored a 95. I mean, you scored a 90%, an A. I did test number 2. I scored an 85, right? Or 80. Okay, who did better? Is the only the knowledge, the the knowledge of the two grades, is it enough to judge who did better?
Not really.
You see, okay, if you score 90%, right?
Huh?
If you score 90%, but everybody else in your class has 95, how you did?
If it's 95, it's good.
How you did? If you score 90%, right? But
Mhm.
everybody else in your class has 90, 95 or 96 or 100. Everybody else has 100 or 96 or 97, but you just scored 90%. Now you see, me on the other hand, I scored 85, but everybody else scored 70. Who did better now?
You
see,
did.
that is
Yeah.
that is exactly that is we're gonna see now. They try to create
Okay.
they try to create a measure that's gonna help us decide who did better. You see, they
Yeah.
call that the Z-score. The Z-score tells you how many deviations, how many standard deviations you are away from the mean. Because to know if somebody did better or did not better, to know if somebody is tall or somebody is short, there is no standard size. Do you have a standard size of shortness of being tall? We don't have that, right? It's all about, the people you live among, okay? If you live among everybody who is like, like 6 feet, stuff like that, you can be like, if everybody is 7 feet, I mean, look at like the basketball stuff. I always thought Stephen Curry was short guy. Why? Because you see them among tall people, right? Way taller than he is. And you think he's short. He's not short. I mean, he's actually taller than me, you see? So this measure that we're about to tell you tells you, try to give you a score regarding, with regard to the mean and with regard to the standard deviation, how many standard deviation you are away from the mean, right? This helps us understand the data better. How many standard deviation we are away from the mean. We call that the Z-score. Z-score tells you how many standard deviation we are away from the mean, okay? Z-score. So let me see the definition of the Z-score, right? Which is here. All right. This is the definition of Z-score right here. The Z-score or standardized value, it is standardized value, is to help us to measure something. Indicates the number of standard deviation a given value is above or below the mean. How many standard deviations, how many deviations you are above or below the mean? You see, this will help us what is if that data is a good data or etc. This will help us understand. A positive Z-score means the data value is the situation above the mean, right? A negative Z-score means the data value is below the mean. A zero Z-score is the data value is exactly at the mean. So basically, if you have, my data is right here. This is the mean right here. The mean is here. If I have a data X, I want to know how many standard deviation the X is above the mean or how many standard deviations X is below the mean. That is the Z-score. And in calculating the Z-score, it can help us answer to the question, who is taller, who is, who did better in something, etc., etc. Because, like I said, if two people are not in the same context, it's very hard to compare them, right? We agree with that? So for instance, it's very hard to compare, like I said, the good example, you have two people in two different classes, they did two different tests, it's very hard to compare who did better, okay? So because you have to take into account the context of the whole classroom, right? You cannot just say, okay, this one has a 65, This one has a 75, so okay, the 75 is better. We cannot say that. Okay, you know, in the absolute, 75 is better than 65 in the absolute, but especially if the two people did the same test, right? Okay, but if you are in two different contexts, I am in here, you are there, we do two different tests. I have a score, you have a score. You have to situate me in my context. You have to say, you have to look how I did first, how I did in my context, and then how much you did in your context, and then you can compare, right? So that is the z-score. So now how to find the z-score? It's very easy. The z-score is of each data. So let me give an example right here. Let me give an example right here. Okay. An example right here, insert, we're gonna give this example right here. We said, this example right here, the tallest living man has a height of 243 centimeters. The tallest living woman has a height of 234 centimeters. Of course, if you put them, if you put them side by side, of course, the man is taller, right? But this is not the thing. This is not the question. The height of man have a mean of 173 centimeters, right? That is the height of man. The average height is 173 centimeters. And the standard deviation is 7 centimeters, okay? The height of women is 162, and the standard deviation is 5 centimeters. Relative to the population of the same gender, who is taller? You see, if you say who is taller, that's it, who is taller, of course, there is no even, you know, that question is not, you know, even, it's not even a question. Because clearly, 243 is more than 234, right? But we're not asking that. We're asking, in their respective gender, who is taller, right? Relative to the population of the same gender, who is taller, right? To answer to this question, we're going to use the z-score. We're going to say the z-score of the man. The z-score of the tallest man, and we're going to say what is the z-score of, I mean, if you are driving, you can okay, thank you very much. Yeah. All right, so the z-score of the tallest woman, we're going to calculate the two z-scores. The formula is actually very simple. It is what? What is the formula? It is the z-score is equal to the data, which is what? This is the data. This is x, right? 243 minus the what? The mean, right?
Mean, okay.
173 divided by what?
7.
The standard deviation, right? Divided by 7. That is the z-score of the tallest man, which means how many standard deviation the tallest man is above the average. How many times he is above the average, right? That's you know, that we need to know to do the comparison. Okay, now we do the, which is what? 243 divided by minus 173 is what? Is 70, right? Divided by 7 is 10. Which means the tallest man on earth is about 10 standard deviation above the mean, okay? The tallest man is 10 standard deviations above the mean, okay? What is the z-score of the tallest woman? We do the same thing. It's gonna be what? It's gonna be, what is the data? 233, right? 233, I mean 234 minus what? What is the mean for the woman? 162, right? Divided by what?
5.
What is divided by 5? 234 minus 162 is 72, right? And 72 divided by 5 is 14.4. The tallest woman is 14.4 standard deviation above the average of the woman height. Now, relative to the population of the same gender, now who is taller now? The man or the woman?
The woman.
The woman, because the woman is 14.4 standard deviation above the mean, right? Which means right here, look at right here. If you have the man, this is the man population, this is the mean. The tallest man is 10 standard deviation, which means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Only 10 standard deviations. This is the tallest man. But for the woman, if the mean is here, the tallest woman is 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right? 14 standard deviation above the mean, which means the tallest woman does better in her gender than the tallest man does in his gender, okay? This is what it means. The tallest woman does better in her gender than the tallest man, in his gender. So relative to the gender, the tallest woman, the woman is taller, right? We cannot neglect this word right here, relative. We cannot neglect that. If we just say who is taller, that's the question, who is taller? Of course, the man is taller, of course, because when they stand side by side, everybody gonna see who is taller, right? But we're not comparing them together. We are comparing them, each one of them in his gender, okay? Like I said, it's the same, it's like, the price of the houses, for instance, right? Okay, you are a house here in Baltimore area. The price of the house is, let's say in Owings Mills, the price of the house is $350,000. And you go to Washington, D.C. in another stuff, you see about the same house, about the same house, but the cost is $500,000. If somebody asks you what house is, what house is more expensive, you're gonna say, okay, if you're comparing them together, of course, the 500,000 house is more expensive because you have to put more money to get it. But if you put them in the context, if you compare the houses, if you situate your house in Owings Mills, you compare them with houses in Owings Mills, what is the average, what is the standard deviation? And then you compare that house in Washington, D.C., near the capital, right? What is the standard deviation, what is this? Then maybe the answer will be different, maybe. Maybe the 500,000 house is less expensive, maybe. See? Everybody in their own context. That is a Z-score. The Z-score allows you to compare two people in different contexts. All right, so let me see if I have another one right here. Okay, so we have okay, which one is here? So we have data from the last 10 years of show, etc., etc. Okay, so let's do the number 9. Again, we're gonna calculate the z-scores for the number 9. All right. You can read by yourself. Of course, you're gonna calculate the z-score for Juno. I don't know, I even don't know how to read that. Juno, right? This looks like it sounds like a French word, Juno. Juno, right? And then the z-score, and then you're gonna do the z-score for Milwaukee. And then you're gonna compare them. All right, what do you say? Which city is having more extraordinary snowfall? Juneau or Milwaukee? Which city has a bigger z-score? Tell me, what is z-score for Juneau? What you do? What is the data for z-score? What is the x? The data is 29 minus 29.2,
20.
right?
Oh, 2.
29.2 minus what? What is average for Juneau?
And 24.
24 minus 24. What is the standard deviation?
3.5.
3.5. That's it. And then we do the calculator thing, right?
Oh, okay, that's how I did it. Okay.
Yeah, 29.2 minus 24 divided by 3.5 is 1.48, right?
Mm-hmm.
The z-score for Milwaukee is now how much? Tell me. 16.2
2.
minus what? What is average for Milwaukee? 15, right?
0.84
Minus 15 divided by what?
divided by 2.8
2.8.
is 10.84.
All right, you said 10.84 or 2.84? It's like 16.2 minus 15 divided by 2.8.
Mommy,
We got 0.42.
0.42.
Yeah, that's what I got. Mm-hmm.
Yes.
Obviously, Juneau, Alaska, is having a more extraordinary snowfall in January because that number A 1.48 is bigger than 0.42. Okay, in this case here, even the snowfall itself is bigger, it's 29.2, right? But the conclusion doesn't come from that. The conclusion doesn't come from 29 is bigger than 50, than 50, no, than what? Than 16.2. It doesn't come from that. The conclusion comes from the z-scores. 29.2 inches is more than 16.2 inches. We agree on that. But the conclusion doesn't come from that. It comes from, we did the z-scores, right? And Juneau has a bigger z-score. Okay, so it is more extraordinary because that snowfall in January in Juneau is above the average, right? More than the snow in Milwaukee was above the average. Okay, you see, for Milwaukee is almost the same thing. Okay, it's more almost that 16.2 is not even a big deal. It's about the same stuff. Okay, but for Juneau, the 29.2 is really, you know, we have 1.48 average. What does it tell you about z-score? They tell you if the z-score is in some intervals, right here, when the z-score is between -2 and 2, it is considered to be usual, right? Even for Juneau, the z-score is 1.48 is not unusual, okay? It's not unusual. To be, for the data to be said unusual, the z-score has to be outside, bigger than 2 or less than -2, okay? For the data to be unusual. When you calculate the z-score for both cities, you got 1.48, we don't consider it to be unusual, okay? It's not unusual. You see, in 29.2 inches, the z-score is only 1.48. It is in the good interval. It is in the green interval. That is not unusual. But if you look at the tallest man and the tallest woman, the z-score for the tallest man is 10. That is very unusual data. The z-score for the tallest woman is 14.4. That is very unusual. Okay. All right. So that is the z-score. Again, that is just a way to compare two things, right? But how we calculate z-score? Very simple. Is the data minus the average divided by the standard deviation. The data minus the average divided by the standard deviation. This is how we calculate the z-score. So you see, the statistic in math always too is all about the basic stuff, right? We just introduce some stuff. We don't dive into we don't ask a lot of questions, complicated questions, which means in the next test, you can take advantage of that. You can take advantage of the fact all the questions that is asked that will be asked in this topic will be some type of basic questions, all of them. What is the mean? What is the average? What is the standard deviation? What is the z-score? What is a histogram? What is a frequency table? What is the relative frequency, etc., etc. So all those questions will be just simple stuff. So now if you go to the syllabus, right? I think if you go to the syllabus, the next test was about what time? The next test was scheduled November the 30th, but this is just like after the break, right? How about we do that the next Tuesday? Everybody. How about we do that the 7th?
Okay.
Do what?
Works for me.
That's the number 3.
That's fine.
Because it's scheduled November 30th. That's just the Tuesday after the break. I don't know how much you guys gonna eat, how much turkey you guys gonna eat, and then forget all the math. You see?
Yeah, I need more time with this anyway, Professor. So I'm not ready for a test yet. I can be honest.
Yeah, so I think
Final or just ordinary test, please.
no, it's gonna be no. Okay. We're gonna give all ourselves time to digest all that right after the break. So we're gonna do in the Tuesday on the break. We're gonna practice more this chapter, and then we're gonna we're gonna start the review for the final exam. We're gonna start that review for the final exam. Okay, that's the Tuesday after the break. Now, the 7th, December the 7th, we're gonna do our test number 3. Same thing with other tests in the first hour. We're gonna do the test number 3 in the first hour. Look, almost everybody did very good in the quiz. Okay, I understand the quiz is different from the test, but if you know how to factor, right? The test is more pressure because I'm watching you. Okay, that is more pressure, but it's still factoring. If you know how to factor, you will have the same questions on chapter 4 on the test, the same questions. And then for chapter 5 and 6, it's this is like basic statistics. What is the table of frequency? What is the median? What is the mean? What is that? Right? You have time to review about that. If you need help, you come to my office hours, right? If you need help. And then something I did is I went ahead and reopened all my open math. I reopened all of them until December the 12th. Now, you can go back if you have time. You can go back and do whatever you need to do in chapter 1, chapter 2. It's going to help you review also, right? So I reopened all of them until December the 12th. And you can also take that opportunity for that to better your homework grade, to make it a little bit better, okay?
Okay.
All right. All right, everybody. So we're gonna dismiss the class today. I wish everybody good holiday. And,
Yeah, happy Thanksgiving, guys.
yeah, happy Thanksgiving, everybody. And see you in a week.
See you.
Thank you.
Bye, guys.
Thanksgiving. Bye.
Bye.